my US ID, and this is my identification. I actually haven't gotten my Gator ID, so that is what I have. Okay, I'm gonna, for the first portion of this section, I'm going to explain why I chose my pKa values for these new amino acids. So I took reference from the table that we were given for the original amino acids. However, I have this about signal and my pKa's because the additional carbon group does change the inductive effect and causes a additional positive charge, which decreases the acidity and raises the pKa. So these about signals determines or signifies that they are not those exact values that we were given. They are actually a little bit greater. So that 4 and 12.5 and 10 would be a 4.5 or 12.7. It would increase a little bit, but I didn't want to specify the value because, well, these are different amino acids than we learned, so I'm not sure by how much it would increase. So that was my take. So this is the second portion. It's the function of protein kinase A within the cell is signal transduction. In other words, it's the transmission of signals. So this protein is actually activated by cyclic AMP. Cyclic AMP is a messenger derived from ATP and involved in the transmission of signals. So upon binding, the kinase A is activated and is able to send signals. And it also has the function of phosphorylation, therefore adding a phosphate group to a specific substrate. These are some screenshots that I took. As you can see here, I took two different pictures because in this phase you could see more alpha helices as I have highlighted, and then in this back portion or of my viewpoint, there's beta sheets indicated by all of these arrows here and here. So let's get to the features. So the features that I chose first are the proline residues, if it's cis or trans. So here I looked for a proline. As you can see, we have to look at these alpha carbons here that I am highlighting. I'll highlight actually in, wait, sorry, here, and here. So directed or seen by the green arrows, these are in opposite directions, so it is a trans proline. If these backbone was directed in the direction of the red arrow, then it would be cis because they would be pointing in the same direction or the same face. So when looking at that, we have to look at the alpha carbons and their directions, and then we're able to determine if it's cis or trans. So look at the carbon next to the carboxyl and then next to the nitrogen proline. So next is the intramolecular disulfide bond. So intramolecular means same molecule. So we're looking at these two in yellow. There's cysteine amino acids. So this bond is a disulfide bond joined by the two sulfurs, and they are within this alpha helix that I have circled in green. so they are within the same molecule. As you can see in this portion, there is another of a different color, so it's not the same molecule. I mean, they're joined together, but they're not the same. So if it was between the green and the orange, then it would be intermolecular disulfide bond. I wasn't able to find, so the only one that I was intramolecular. Next is the parallel beta sheets. So the parallel beta sheets are seen here. They are joined together by the hydrogen bonds. This is between within the oxygens and the nitrogens. You actually can't see the hydrogen bonds with the attached to the hydrogen or the oxygen, but that is what is actually attached, not the oxygen nitrogen per se. And these actually have a 120 degrees, therefore their bonds are slanted, as you can see by the green highlighted area. Next is the intramolecular hydrogen bonding. So intra, same within the same molecule. These hydrogen bonds, as I pointed out, can be between hydrogens of both OH groups or a nitrogen and hydrogen of a nitrogen and a hydrogen of an oxygen. So these are all by this dashed bonds. Next is the antiparallel beta sheets. So we said parallel was 120 degrees, therefore they were slanted. Here they're 180 degrees. So they are straight hydrogen bonds that form those beta sheets. Okay. Perfect. As you can see here, I wanted to point out that, yeah, you can't see the hydrogens, but here, if you are able to see that this is arginine. So we have NH, NH2, and NH, and this is connected with this H from the oxygen and from the nitrogen. Just pointing that out. Next is, so an interesting fact about myself is that before COVID, I opened a online thrift store with my best friend. It was, the goal was to reduce the carbon footprint caused by the decomposition of clothes, and we created the website, the logo. We had to register it to the state of Florida, and it didn't really no one actually bought anything because COVID happened. So it was a failed business, but it was great because we actually knew how hard people will work for having a great website and having an advertising, getting actual customers. That was actually a great experience, and a lot of people supported me. It's named. The website actually still exists. It's called SNS Society. My name is Sabrina. My best friend's name is Cynthia. So SNS, it was cool. We made it, and yeah, it's a failed but experience. But yeah, we learned something from it, and I'd say it was a good experience.